is that we're going to finish talking about these word problems real quick. We're going to also talk about how to calculate the inverse by hand. Now, the stuff that we do for inverses, obviously, yeah, that's really late. You gotta get a pass for that, buddy. All right. What's going to happen here with these inverses? Obviously, throughout these last couple of sections, we've been using inverse matrices to solve problems, to solve systems and whatnot. But now what I want us to be able to do is just crank them out by hand. You won't have to use an inverse matrix by hand into the system stuff that we've been doing. But I want you to still be able to crank a 2x2 without much of a hassle. That'll take about 15, 20 minutes to talk about. So we left off here. Sort of without it. We left off here, we're talking about the that matrix C. And within matrix C, if the idea here was that we were trying to maintain all of our different dimensions and what all those dimensions meant. In matrix C, when they said create that 1x4, it was talking about the order, that was what they were asking, the order that was placed, and the amount of goods. So the order was the 1, and the goods were the 4 columns. Now, as you read into the question further, in number 5, it says use multiplication matrices to find the amount of each ingredient needed to fill the day's order from question 4. Now, here's what happens. If you look at the 3 different matrices you have matrix A, which was a 4x5. It dealt with the goods and the ingredients. Matrix B was a 5x2, dealt with the ingredients and cost. Matrix C was the order and the goods. Now, in order to figure out the amount of ingredients you're going to wind up needing, the order needs this many ingredients was to match up matrix C times matrix A, a 1x4 and a 4x5. The goods in the columns and rows basically negate one another, and you create a new matrix that deals with the order and the ingredients. When you get to the last question, it's asking you to find the final cost. Well, you're using that combination matrix you just created, which wound up being a 1x5. So you have order, ingredients, times matrix B, which is ingredients, cost. So you have to do a little bit of extra work there. 2 columns that would have been created would have been a large lot price list versus a small lot price list. Or small, large, I'm not sure how they went versus the columns. But the exercise here that I was really hoping you guys were figuring out as you're going through here was the fact that how you can use matrices to match up specifics within a word problem. In this case, they're dealing with ingredients. On the outside, you have the order versus cost, order versus whatever. So that was kind of the idea between that one. Now, when we get into the other stuff that we were looking at, on the pages themselves, let me get mine out. I think we left off with the area one. Now, most people, when we got to that area question, we kind of got to the point where we knew that to solve the area of the triangle, all you had to do is the determinant, take plus or minus 1/2 of that determinant. Now, I know a lot of people, third hour, kind of looking at that problem going, Murphy, it's a right triangle. I can just count and do the 1/2 base times height. Yes, absolutely, you can do that. But here's the deal. When on the test, we're going to have ordered pairs. Just make sure you remember how to set that up. The question that people were coming up with about what do you do after you get those areas was with number 57. Now, on 57, it said that suppose you wanted to make a scale model of the sailboat with sails shown using a scale of 1 inch to 6 feet. What's the area of the model's mainsail? So what happens is you have to take the area of the mainsail. I think the mainsail was 144 square feet. Now what you want to do is you want to scale that down. So you're looking to make it in terms of inches. 1 inch took care of, what was it, 6 feet? What do our dimensions match up here to be able to to be able to simplify the dimensions out? No. What you have to do to this is square it. Because then you get 144 square feet, times 1 square inch over 6 square feet. Now your dimensions drop out. It just winds up being 144 divided by 6. I believe you get 24.
Was that the answer for
Yeah.
That's the answer for 57?
Not, I'm sorry, 36, 36. I don't know why I didn't square the
Yeah,
6.
I was
Hello. It should be 4 then. Yeah.
Okay, yeah. All right.
144 divided by 36. Sorry about that. I was thinking of a different problem. What's the answer? What would the area of the model be? The area of the model would be 4 square inches. So if you're scaling that down, the area of that model would be 4 square inches. Yeah, let's.
I did this probably wrong, but just to check to make sure.
Did you do it where you counted the ordered pairs? Did you make it like 12-1 for the y values? Oh, what'd you do?
I instead of I thought it was in inches going to feet, so multiplied by 6. Can you still do that?
No, because it's. I see what you're saying. Yours would have wound up being a larger value.
Right. Yeah.
You still would have had to square it. If you wrote it as 144 square inches,
Yeah.
did you have this as just 6 inches?
Yeah.
Yeah, you would have had cubit stuff. You would have messed up pretty bad there. You ever had a black hole in one?
And
Cats,
the
dogs.
guy hazardously.
Yeah, cats, dogs live together. Complete peril. Save you, right?
I feel like you gotta get a matrix for number 59.
Yeah. Can you set it up there real quick?
Yeah.
Absolutely.
I just
Number
did.
59, we're talking about gas. Now, in order
Where
to,
are we at?
not talking like gas, we're talking about gas. Yeah, that's funny. Okay, anytime you can. Anyway. Now, in this case here, what you're starting with is a system. And you have to develop the equation before you can create your matrix. So you have to be able to figure out what is it saying. Well, you fill up your car with 10 gallons of premium and a small gas can with 2 gallons of regular gas. You paid $13.56. So right now you know that 10 gallons of premium and 2 gallons of regular was $13.56. You also know the following. Premium is 12 cents more than regular. Now here, how do you get this into a matrix? Well, think about the way matrices work. Matrices will always have both variables on one side and the equal number on the other.
Right.
Subtract r. Rewrite this second equation so it's p minus r is 0.12. Now I have 2 variables, 2 equations.
I feel.
So then from there you do
I
From
think
there
I
you get
did this, but it turned
10,
out
2, 1, negative 1. Now, what this column matrix becomes is your premium and your regular, and that equals 1356 0.12. How do you get that premium and regular gas by itself? You inverse. So what happens is you just take the inverse of this matrix, the 10, 2, 1, negative 1, and you multiply that against the 1356 and the 12 cents, and you'll find out that gas was really, really cheap when this book was written.
So we have to do the.
$1.15? $1.15 is very cheap. What's that?
So you have to multiply it. So the inverse times.
Yeah. We write it up, put the inverse times that, and then it'll work
So
straight.
it's just straight multiplication.
Yep. You put it right in your calculator just the way this is, and your answer's gonna be, I think it was $1.15 and $1.03, or is it $1.05? $1.03. So regular gas was $1.03. And when this book was written, about right around 2000, it might not have been $1.03, it might have been a $1.30. I remember when gas first hit $2, everybody was like, oh my God.
Wasn't it in like 2005? Maybe.
That's about right. 2005, 2006, somewhere in that neighborhood.
And now it's $4.
I love the fact that sometimes, I remember when I was in high school, you know, when I first got my license, it was 1991. My parents, I was, you know, the oldest, my brother and I was the older one. So as soon as I turned 16, I turned into the Gopher. Those of you guys that have turned 16 and have access to a car sometimes, you will know what that means because you are the Gopher. Go for this, go for that. They would give me $20 and say, go for a gallon of milk and fill up the car, and you can keep the change. So I'd go for a gallon of milk, maybe a loaf of bread, and fill up my parents' car, and I would come back with $8 in my pocket extra, or $5 extra to do all that. Well, because now they have to give you a $100 bill to go fill the tank. So, I think it's funny like when gas gets over like 410-ish, if I don't fill up my tank before it's at a quarter tank, I have to use my credit card twice. Because 30 gallons and it goes over the $100 mark, and your credit card shuts you off at $100.
Well, you just change the limit. That's a little bit.
Whatever.
Because it's not that bad, it's just tall.
I don't care.
I'm just.
I really don't.
Well,
I sit there, it's,
what would the fridge do?
the fridge can say I don't care.
He said, credit card.
Wait,
I got 100.
How often I fill up?
Living on this credit card.
I don't know.
Who needs money?
A couple of weeks, 3 weeks or so. I don't drive that much. I really don't. I mean, my commute is, I put 7 miles on the car a day, maybe 8, if that. So,
I only put $9 in the first week.
all right. Not so scary, was it?
No, that's scary. I didn't know.
That's scary.
That, I'm
Oh, I've been idiot sometimes. All right, so 41 dental fillings. This is another outdated problem because they don't use copper, silver, or tin in your mouths anymore. They use Quickcrete.
Quickcrete.
They use cement. It's that white cement. They got a little wheelbarrow off back. They got a hoe, they're garden hoe, they're mixing it up together. They do not been to the dentist lately?
They actually.
They fixed it. I think I had one of those ones for a while.
How do you think they fill in the holes? What are you filling it in with, like gum?
Yeah.
Egg yolks?
They may not stir it back with a shovel.
Anyway, so what happens in this problem, guys, we got a lot to get through real quick here. They're giving you the original matrix to start with. You have to figure out what are you finding. Now here's what's happening. This original matrix, as they're shown to you in the table, talks about in the rows are the silver, tin, and the copper, and how much each of those alloys you're using. The amalgam? Amalgam.
This one was easy.
I have no idea.
Basically, once again, you're multiplying it against something that A, B, C to give you that 5483, 2009, and 129.
Is that ABC?
Yeah, because that's the. Once again, in order to solve the A, B, and C, what button do you press on your calculator? You use the inverse again. You will get some nasty looking numbers, but remember, they're just talking about something in grams. They're talking about something with a decimal point at the end. Yes, sir?
The second one copy.
Oh, I gotta get my plug.
I have,
Wait, does anyone have it?
I got 1, 3, 1.
Yes, that sounds right.
13.6.
Yeah,
Yeah.
13.6, that sounds right. So I remember seeing those digits happen.
5,009 is gone, but I didn't have it.
Let's get to the ones where you have to spend a little bit more time writing about.
42?
Yeah. Stained glass. Now remember when we're talking about, if you use some of the techniques as to when we were working with linear programming, I know you shudder when you think about that. That's what's scary. When you get into thinking about linear programming, you guys are always looking for information within the problem, talking about costs, talking about different constraints, if you will. Now in this problem, it's not these aren't linear programming style, but you can still use that same kind of attack to figure out what's going on. So as you read through this, you're talking about making some mosaic tile. You need 6 square feet of glass, and you want to be as much iridescent glass as red and blue combined. Also, it says the costs of the areas, all the areas of the tiles are 3/4, so 0.75 square foot for all of them. And then it gives you 3 costs. So what happens here is you break it down into 3 variables, 3 equations. So the first thing they're discussing here is that you want 6 square feet total. Well, start with what they give you. Well, the 0.75 iridescent, 0.75 I, plus 0.75 red, plus 0.75 blue. That will give you the total amount of square feet. The next part talks about,
Oh, that's.
yes. If you read the problem, it talks about you want the iridescent to be as much as the other two combined. And then lastly, they're talking about price. You've got 45 bucks. So it's 6.5 for the iridescent, 4.5 for the red, and 5.5 for the blue to be equal to $45. Now, when you look at that system, we have 3 variables, 3 equations. Do you agree? One of those equations is not quite ready to be put into a matrix form. The I equals R plus B. I need to make this look like the other two. If you look at the other two equations, you'll notice that all the variables are on one side, aren't they? So what is this going to equal?
0.
It'll equal 0. What do you do with the R and B?
Subtract it.
Good. So you get I minus R minus B is 0. Because I want to put, on the other equations, it was lining up I, R, B. I was moving everything that way. And now you have a 3x3 system. 0.75, 0.75, 0.75, 1, negative 1, negative 1, 6.5, 4.5, 5.5. What do you think we have to do to this matrix as we go to solve it? Inverse, and then I multiply it to the 6, 0, 45. And that will give you your answers in terms of I, R, B, in that order. Okay? Remember, any problem that we have done that was a word problem, whether it was chapter 3, chapter 4, chapter 2, any of those things at all, if there was anything with the system, cover it, we didn't finish it. I'm not yelling at you yet. It's pretty obvious that we covered it. When you get into these types of problems, any one of them that we have done, you can still solve via systems. You can use the matrices. Every single one of them can be solved with a matrix. All the ones you guys got mad at me about. Okay?
No, I just did one from the test. And it was like 0, 0, 1.
Makes no sense.
Oh. Okay? And then there's one left. 43 should have been really easy because they gave you the 3 equations. The only thing that people tend to forget about in number 43, you forget to put T in the equation. You have the transformer. You have one transformer,
Oh, yeah.
25 feet of wire, 5 lights. One transformer, 50 feet of wire, 15 lights for $35. One transformer, 100 feet of wire, 20 lights for $30. So aside from writing out the full system, they give you the equation right there. Most people forget to put the transformer in there because it's a 1 and you don't see the number, that's all. Take the inverse of it, it'll give you the answer in terms of costs. Cost for the transformer is the top one, cost for the wire is the second, and cost for the lights is third. Yes, you will get a decimal for your wire. That just means it's so much money per foot. Because in the problem it's talking about 25 feet, 50 feet, 100 feet. I believe you get 0.2, so it means it's 20 cents a foot. Think of it this way, if you've been to Lowe's or Menards or something like that, they sell wire by the foot. That's what you're doing. You're buying 6 feet of wire, at 18 cents a foot or whatever it might be. Okay, you can purchase those types of things by
But the answer is just y equals 0.2 good though?
Well, yeah, because that just means it's 20 cents. Because your answer, you're going to get an answer setup of 10.2 and 1. Well, this means it's $10 for the transformer, 20 cents for the wire. And what was the last one? $5?
I don't think
I
a
didn't
lot of
actually.
people are on the
I
same.
got like 16.6.
Yeah.
Yeah, I got like 16.6.
This is either 20, 35, or 30, and it's 25, 20, 35, 50. What?
It's just 30 though.
What?
You put the wrong number up there. That's why you guys got it wrong.
Yes,
That's
Oh, sorry, it's supposed to be 50. That's why you guys got it wrong. I wrote down the problem wrong. I thought it was a 30 for some reason. Sorry about that. Well, if you would have done your homework before this,
Yeah.
that means your domains were bad. You were multiplying incorrect size matrices.
Yeah, I tried to
Oh.
I tried to get the answer.
No, the reason why you're getting an error message is because the determinant, when you do the inverse of this, it's telling you that the determinant was 0. And you can't take an inverse with the determinant of 0. That meant that this first matrix was typed in incorrectly. Okay, and we're going to explain why that happens. So, what I want to do here today now is go back into the 4, I believe. And I want to talk to you guys how we can calculate an inverse by hand, because you will have to do that on Monday on the by hand portion of the test. I will go back and do another word problem here in a minute, but I wanted to spend about a good 10 minutes or so talking about inverse stuff by hand. I'm not collecting this because these are all good problems to continue to revisit. I will give you another 2 problems to look at tonight. Yes, sir.
Did they, the hand problem on the test, is that a word?
There won't be word problems on the by hand portion because a lot of these things you have to do inverses and then multiply. I'm not going to have you crank out this inverse by hand and then have to multiply that out. It'll take you all day. All right. So let's talk about what an inverse looks like again. There we go. Now, we didn't really get a chance to talk a lot about this to start out with because I wanted you guys to start using inverses right away just to see what they're used for. Now, the reason why we have inverses is so that, well, obviously, so you can solve systems of equations. Now, one of the things that you might have incurred when you were doing some of these problems in the past day or two is you might have come up with an error message on your calculator with was it invalid domain? Where it would say invalid domain. There's a reason why that happened, and I'll show you this real easy here. What happens when you take a determinant? When you take a determinant, you're taking your downward diagonals, subtract the upward diagonals, correct?
Yeah.
Now, sometimes that determinant could equal 0. Agreed?
Agreed, sir.
It is possible. When you do and work with an inverse matrix, you wind up with the following step. First thing you do is you always find the determinant. Let me put this up on the board while we're talking about it. And we're only going to be doing this with 2x2s. So whenever we're working with an inverse matrix, the very first thing you do is find the determinant. In this example here, I'm looking at matrix that is 3, 1, 4, 2, respective. So when I go to find the determinant of that, I multiply my downward diagonals and I subtract my upward diagonals. Oops. In other words, this becomes, well, first of all, the determinant of A, well, 3 times 2 minus 4 times 1. Otherwise known as? Yeah, that's perfect.
Yeah, if you swore.
Yeah. It's otherwise known as 2. So now what you do is you take that determinant and you put it under 1. So it's 1 over the determinant of the original, and you multiply that against, well, here's where you get those funky looking fractions. Exchange the downward diagonals. So instead of being 3 and 2, it becomes 2, 3. You're flip-flopping them. You flip-flop the downward, and then you negate the upward. Negate, you put in a negative symbol in front of it. You negate
And what is it put in?
to find inverses. And we use inverses whenever to solve systems. Yep. And now all that's left to do is distribute the 1/2 into all 4 of those terms. What's half of 2?
1.
So you get 1, negative 1/2. What's half of negative 4? And then 3/2. Do you remember when you were doing these things with the calculator, you're getting those funky looking fractions? Remember 17 over 10 and so on and so forth? Negative 3/5, things like that. This is why that happens. Because you take the determinant, you put it under, you put 1 over the determinant. You were getting these weird setups when you were multiplying it in distributively. Yes.
So where did the half come from? That's just what you use, or?
You take the determinant of the original, and it's 1 over the determinant. It's just 1 over the determinant equal times the flipped around matrix. But if you do a couple of them, it's really easy. Okay? So we're trying to find yes.
So you switch 2 and 3.
Uh-huh.
You stay positive and you switch 1, but 1 and 4 you can
Correct. You switch the downward, and you negate the upward. And what I mean by negate, I'm just putting the negative symbol in front of it. Now, if this was and I want to find the inverse of this. The first thing that I do, once again, is find the determinant. Negative 8 minus negative 18. Do you agree on that? What do you get? 10. Now I take 1 over that determinant, exchange the downward, and I negate the upward. So I put a negative symbol in front of the 3, and how do you negate a negative? It becomes positive.
Okay.
Do you see that now?
Yeah.
And now what do I do with that 1/10?
You multiply.
Yep, distribute in.
Yeah.
All right, now this is going to become really difficult. What's negative 2 over 10?
Negative 1.
Good. 6 over 10.
Negative 3/5.
Negative?
What? Yes.
Same thing. Okay.
Same difference.
Then, see, you just have to remember simplify your
Say
fractions.
that.
And the fractions here shouldn't be that bad. You won't be able to. You'll be able to figure them out by hand.
You go right to the one you would just do it, or that's not bad.
Sure.
I want 3 by 3.
We're not doing those by hand.
Can you do it by hand?
I don't remember how. Not gonna lie, I really don't remember how. The book doesn't show, and I really don't remember how to do them. How to do
I don't
the
blame you, Mr. Murphy.
a 3 by 3. I really don't remember what the pattern looked like. I honestly don't. You can look it up. There's this great thing on the computers nowadays called Google.
School Wi-Fi is not working right.
You have to rub the Wi-Fi in your hair to get a little extra static, and you'll be all right.
Thank you.
Yeah. Yeah, right. That's all you gotta do. So easy. So the inverse. Now remember, this is the answer. That's the answer. That's the inverse of the matrix.
Just like
Leave it like that.
1 over 10 times.
Times negative 2, 6, negative 3, 4, and it equals that. So this matrix here is the inverse of that matrix. If I was to multiply those two matrices together, I would get the identity matrix. 1 on the downward diagonal. Okay. Remember, if you multiply a number by its inverse, you get 1, right?
Right.
2 times 1/2 is 1. 33 times 1 over 33 is 1. When you multiply it,
I got it.
when you multiply a matrix by its inverse, you get the identity matrix, which is 1s along the diagonal. And it works for any dimension matrix if it's square. But we're only going to deal with dimensions. Now, I'm not gonna have you guys, because all the times with every one of these problems we've done as far as solving systems and stuff are concerned, you're always using inverse matrices. I'm not gonna have you do that by hand, because then you'd have to multiply that fraction stuff into another thing and simplify stuff out. It just becomes a nightmare. Can you imagine having to do that with those problems we did earlier with the word problems with the decimals? That was in the section that you didn't know how to do these by the calculator yet. They expected you to be able to do those by hand. I wouldn't want to do that by hand. Nope. Not happening. Okay. Questions? Want to do another one?
Yeah, let's do another one. Good old practice makes perfect, eh?
Find the inverse, please.
Zero.
Oh, it is. It's undefined. It won't work. Sorry. Remember,
Oh,
error. I get. How about that for randomness? Remember, if the determinant winds up equaling 0, your inverse will not exist.
In a logical plan.
No, it's not 0, it's 48.
Yeah.
Come on, guys.
Negative
48.
4.
Well, let's say it was 0. Let's say it was 0.
Here, let me, take
Yeah.
this.
So on the test, that's just what the problem would look like.
Yeah.
And we
And let's say find the inverse of this matrix.
And then, okay.
Yeah. If this will not exist if the inverse is 0, or excuse me, the determinant is 0, because when you go into the problem, you have to take 1 over the determinant. Can you divide by 0? No, that's what happens. It's bad things. And you're right, yes, I can't do math in my head, so this would have worked. What was it again? 48. So it'd be 1 over 48 going into all that junk.
Should we do it out?
Yeah, these fractions aren't that bad.
Yeah, but I can't do that without a calculator.
3 goes into 48 how many times?
I'm pretty sure it.
3 goes into 4 how many times? How many are left over?
Mr. Murphy.
How many times is 3 going to 18?
6.
Oh, yeah.
Mr. Murphy, you gotta switch them around.
You know, I'm doing a good job of making sure you guys are paying attention.
There you are.
Sure you are.
Negative?
Yeah.
And now you simplify. What is that? We have what? That was at 6.
Hey, what do you want?
What over 6?
Hey, 1 6, negative 1 8,
Ah,
negative 1 12.
it's positive 1/8. Remember, you have to negate. You switch you switch your sign around, and then this is.
Am I blind? I thought there was not a negative sign. Like,
I put it back on there because remember the first time I had the negative there, then they said it was 0, so I said, well, Dave told me, oh no, you don't have to math. So we had to put the sign back in to make it look like we knew what we were doing.
I was like in my mind, I
Yeah,
swear to
that's
God,
how
there's no
isotope.
negative sign there.
What do you get? Negative 112?
Yeah. Yeah.
And then 116.
Yeah.
You should be able to do simple fractions like that. You should know how to divide by 3.
Sure.
Hope so. That's an easy fraction.
1,
Divided by 3.
3, 4.
Alright. So here's what I want you guys to look at with these things for this weekend.
Any more problems?
There are, the two problems that I want to look at as far as inverses, they are on page, this is the wrong section.
Should I do them in my notes or should I do them on?
I would do it on a separate sheet of paper just so we have them. The wrong section again. Yeah, here we go.
Hey, Willis.
The inverses. On page 220, this is section 4.4, page 227. I want you to do 19 through 21. I'm giving you, obviously you can check all these answers with your calculator, but I'm giving you a couple in case because I want you to do this without your calculator, the odds. What? Yeah. That's what we'll work on. And then the other one is in section 4.5. The other one is on section 4.5, and it's between page 232 and then 233. It's working with number 10, but number 10 deals with example number 4, the page earlier. And the reason why I wanted to give you this problem specifically is because it helps you with the setup and how you come up with the actual model on the page before. So you're able to change values around to solve number 10. Okay? It gives you a big old giant hint as to what's going on. You got some time in class? Go ahead.
Alright, determinant is
No, it does not say that.